Okay, so one of the basic strategies for solving radical equations is to first move everything on the outside of the radical to one side and all the radicals to the other. The second step would be to get rid of the radical with the appropriate power, and then the third step would be to just finish isolating the variable. In some cases, you may have to kind of repeat steps 1 and 2 until the radical is gone. So we're going to be solving the equation, the square root of the sum of x and 8 minus 3 on the outside, and then equal to 2. So in general, the strategy we're going to use is we're going to remove everything on the outside of the radical. So I'm going to simply add 3 to both sides, leaving us with the square root of x plus 8 is equal to 5. And then we'll get rid of the radical itself, and the opposite of square rooting something is using our power, which would be squared in this case. Squaring and square rooting will cancel out, leaving me with x plus 8 equals 5 squared is 25. Now that the radical is gone, we just have to finish solving for x. So subtract 8 from both sides in this case. So we'll have x equals 17. Remember that some cases at this stage where you're trying to get x by itself, it might be a linear equation, it might be a quadratic, it just depends on the problem. We should always check our answers for these because sometimes we do have extraneous solutions. So now that I have my possible answer of 17, we're going to go back up and just double check. 17 plus 8 minus 3 is that 2. 17 plus 8 is 25. That's underneath the square root. The square root of 25 is 5. So 5 minus 3 is indeed 2. So it does check out. So 17 is indeed the answer. So in this example, this is one of the kind of exceptions to our basic strategy. We do have stuff outside of the radical. We have this 3, but it's connected by multiplication. So we really just have a single radical on both sides. In this case, we don't want to try to move all the radicals one side and everything outside to the other. There are rare cases where we don't follow that approach. In this case, we're just going to try to square both sides, and we're squaring it because we're working with square roots. So as I square both sides here, squaring and square rooting will cancel out the radical, leaving us with x minus 8 on the left. And on the right, because that 3 is connected by multiplication, we're going to have to break this down. According to exponent properties, specifically the power of a product, we raise each factor here to the second power. So we'll raise 3 to the second, and we'll raise the square root of x to the second. 3 squared is 9, so we have 9 times the square root of x squared, which is just x. So 9 times x, which is 9x. From here, we continue to try to solve the equation. Well, we have to move all the x's to one side because it's linear. So I'm going to subtract x from both sides, giving me negative 8 equals 8x. And then I'll finish off by dividing both sides by 8, giving me x equals negative 1. Now that I have my possible answer, I have to go back and try to plug it in. And if we do that, plugging into the original equation, we have negative 1 minus 8 equals 3 times the square root of negative 1. Well, this is a big red flag. Having a square root under a negative does not work, which means this is not actually a solution. So we just have no solution. In this example, we're going to be solving another equation. So we have the square root of the sum of x and 2 with the plus 10 on the outside equal to 1. So taking the typical approach, we're going to get rid of anything outside the radical by subtracting 10 from both sides, giving us the square root of x plus 2 equals negative 9. The next step will be to square both sides of the equation to get rid of the radical. In doing so, we'll have x plus 2 because the square root and the squaring will cancel, equals negative 9 squared is positive 81. Then we just have to finish solving by subtracting 2 on both sides, giving us x equals 79. However, if we go back and check this, plugging our 79 into the equation, we have 79, the square root of 79 plus 2, plus 10 on the outside, equals 1. Well, 79 plus 2 is 81. Square root of 81 is 9. 9 plus 10 is not 1. So what threw this off? Well, this line right here is what throws it off. The square root of something never produces a negative value when we're talking about the principal square root. So the square root sign written already. So since 79 doesn't actually work, it's an extraneous solution, and once again, we have no solution. Okay, so in this one we're solving another equation. This time though we have a cube root, so we have the cube root of the sum of x and 4 with a plus 8 on the outside equal to 5. So we're going to start by getting rid of anything outside just like we do for square roots. So we'll subtract 8 on both sides, giving us the cube root of x plus 8 or x plus 4 equals negative 3. And this time when we get rid of the radical, we're going to be cubing both sides instead of cube rooting, or instead of squaring. Cube rooting and cubing are opposites or inverses and will cancel out, leaving me with x plus 4 equals negative 3 to the third, which is negative 27. And then we have one more step to finish getting x by itself, subtracting 4 from both sides, giving us x equals negative 31. If we go back and try to check our answers here, plugging in the negative 31, we'll have the cube root of negative 31 plus 4 with the plus 8 on the outside. Negative 31 plus 4 is negative 27. The cube root of negative 27 plus 8 should be equal to 5 because the cube root of negative 27 is negative 3. And if we add that to 8, we do indeed get 5. So negative 31 is the correct answer. So in this one, we're going to take the same approach. However, this equation is an equation with a rational exponent. But just like with the radicals, we're going to take the same approach since a rational exponent is just a combination of an exponent and a radical or a root. So we're going to get rid of anything outside of the radical first, or outside the parentheses. We need to start by getting rid of addition, subtraction outside, which there is none. Then we'll get rid of multiplication on the outside. So we'll divide both sides by 2 here, giving us x plus 5 to the power of 3/2 equals 8. Now to get rid of the rational exponent, what we're going to do is we're going to raise both sides to its reciprocal power. So the reciprocal of 3 over 2 is 2 over 3. So we're going to raise both sides to the 2/3 power. On the left side, the exponents are going to cancel out, leaving us with x plus 5. On the right side, we'll have to evaluate the 8 to the 2/3. Remember that it is really a combination of the cube root and squaring, meaning we're doing the cube root of 8, which is 2, and then 2 squared, which is 4. So 8 to the 2/3 becomes 4. Don't forget, if the bottom number is even, we would have to consider both positive and negative cases for this, and then go back and check those answers later. But since the bottom number is odd, we don't have to worry about the plus minus, the positive and negative cases. We'll finish getting x by itself by subtracting 5 on both sides, leaving us with x equals negative 1. We still do have to go back and check our answers though. So if I plug negative 1 back in to check, we have 2 times negative 1 plus 5 to the 3/2 power. equals 16. Well, negative 1 plus 5 is positive 4. 4 to the 3 halves power would mean I am doing the square root of 4 to the third, which is, well, the square root of 4 is 2, and then 2 to the third is 8. So we'll have 2 times 8. Is that 16? Well, last I checked, 2 times 8 is indeed 16. So negative 1 does indeed solve the equation. Okay, so this is another one here. We have the cube root of x minus 5 equals the 2 cube roots of 7 minus x. It's another one where we have a radical equal to more or less a radical. And this number on the outside is connected by multiplication. If it's connected by addition and subtraction, we would need to take a different approach here. But since it's connected by multiplication with no addition or subtraction outside the radicals, we're simply going to cube both sides to try to get rid of the radical right away. If I do that, cubing and cube rooting cancel each other out, leaving me with x minus 5. And then on the right side, because there is the 2 connected by multiplication on the outside, I will separate it into 2 to the third times the cube root of 7 minus x to the third, applying exponent properties, specifically the power of a product. 2 to the third is 8, and when you raise the cube root to the third power, they'll cancel out, leaving us with 7 minus x. Now it's very important that we remember parentheses because there are 2 terms with this expression. So now we can finish solving, so I will have to distribute here. So we have x minus 5 equals 8 times 7 is 56 here, and then 8 times negative x is negative 8x. Then from here we just have to finish solving this equation. This is still a linear equation, so I'm going to move all the x's to one side. I'm going to add 8x to both sides, giving us 9x minus 5 equals 56. Then it's a two-step equation from here, so we're going to add 5, giving us 9x equals 61. And finishing it off by dividing by 9 on both sides. So x will be 61 over 9, which we cannot reduce. And because this is a little bit ugly with the fraction and the radical, I'm just going to use a calculator to kind of help check it, but I will plug it back in. So the cube root of 61 over 9 minus 5, is that going to be the same thing as twice the cube root of 7 minus x, which is 61 over 9. And if I try to type this into the calculator, I'm going to get a number that's approximately 1.211. On the right side, if I try to type that into the calculator, I should get about the same thing, or actually exactly the same thing, because they are indeed equal. So in this example, we're going to solve the equation and make sure to check for extraneous solutions. So we have the quadratic expression x squared plus 5x plus 5, all raised to the 5/2 power, set equal to 1. So for this one, since I only have one exponent, I'm going to start by getting rid of the stuff outside of the fractional exponent expression, so outside the parentheses, which is just the fractional exponent. To get rid of a 5/2 power, we're going to raise both sides to the reciprocal power, which is 2/5. So raising both sides to the 2/5 power, the 5/2 and 2/5 will cancel, leaving me with x squared plus 5x plus 5 equal to 1 to the 2/5. Now remember what this is actually meaning is it's meaning the 5th root of 1 to the 2nd power, which is still 1 because 1 to any power is 1. Now the resulting equation here this time is a quadratic, so I have to solve it like a quadratic, which means I need to get it set equal to 0. So I'm going to subtract 1 from both sides, giving me x squared plus 5x plus 4 equals 0. There's many different ways I can solve a quadratic. Two most common here would be quadratic formula or factoring. Factoring should work, so I'm going to try that. Multiplying my first and last. Combination that will add up to be the middle term, but multiplied to be 4 is 1 and 4. And since there is no leading coefficient, I can jump straight to the factors of x plus 4 and x plus 1. This is a solve equation question, not a factor question. So I set each of those factors equal to 0. So x plus 4 equals 0 and x plus 1 equals 0. And then I solve each of those. Subtracting 4, giving me x equals negative 4. And subtracting 1 from both sides, giving me x equals negative 1. Okay, so I'm going to use Desmos here to check it kind of quickly. So we're going to be plugging each of our answers into this, and hopefully, if we plug our answers into the left side here, for x, we should get 1 out. So that is our hope as to what's going to happen here. So if I try to do this, we have parentheses, and then we're going to need a double-sided parentheses so I can get the x squared. So negative 1 is my first, or negative 4 is my first possibility. To the second power, plus 5 times negative 4. And then plus 5. And then all of this is raised to the 5/2 power. So I'm going to need my exponent in parentheses, 5 over 2. And you can see that we do get 1 out if I type that in. And if I try to do the same thing, except replace the negative 4s with negative 1s, you can see we also get 1 out. So it looks like both of these possible answers here solve the actual equation. So we have 2 answers. In this example, we are solving a radical equation. This time we have addition and subtraction outside the radical. So even if it was on the same side, for example, a format like this, we would want to move everything outside the radical to the other side, since there's stuff connected by addition and subtraction. So starting off, everything's already on the other side though, if it's outside the radical. So we're just going to start by trying to get rid of the radical, squaring both sides here. Squaring and square root will cancel, leaving us with 3x minus 2 equals, if I do x minus 4 squared, you can either use the property to distribute it out quickly, or you can write it out twice and then distribute like normal. No matter which way you approach dealing with x minus 4, the difference of x and 4 squared, you should still get x squared minus 8x plus 16 after combining like terms. Now this particular problem comes out to be a quadratic, so we're going to have to move everything to one side. And since my squared's on the right, I'm going to move everything to the right. I'll subtract 3x to do it, and I'll also add 2. So that's going to be 0 equals x squared. Negative 8 minus 3 is negative 11x plus 18. I'll continue solving by multiplying my first and last, choosing to solve this quadratic equation by factoring. The combination that multiplies to be 18 but adds to be negative 11, I believe is going to be negative 2 and negative 9. Since there's no leading coefficient, I can jump straight to the factors of x minus 2 and x minus 9. Now, this is still set equal to 0. This is a solving question, so we still have to finish it. We'll set each of our factors equal to 0. X minus 2 equals 0, and x minus 9 equals 0, and proceed to solve each of those one-step equations, adding 2, giving us 2 as one of our possible answers, and adding 9, giving us 9 as our other possible answer. So remember that we have to check our answer. So if I go back up to the original equation and plug our two x values in, so over here is my check. If I plug my 2 in, so 3 times 2 minus 2, is that going to be equal to 2 minus 4? Well, 3 times 2 is 6. 6 minus 2 is 4, right? And then this is still underneath the square root. The square root of 4 is 2. But is that equal to 2 minus 4, which is negative 2? No, 2 and negative 2 are not the same thing. So x equals 2 does not work as a possible solution. If I go back up and try 9, which is my other possible answer, just replacing those. So my other possible answer is 9 here. If I plug a 9 in, 3 times 9 is 27. 27 minus 2 is 25, so we have the square root of 25. Square root of 25 is 5. Is that equal to 9 minus 4, which is 5? Yes, they are equal. So 9 is the answer, and the only answer. Okay, so in this example, we are trying to solve a radical equation. This is one of the more complicated cases. Notice that we have two radicals on one side connected by addition and subtraction, and another number on the other side. If we were to try to move one of these radicals to the other side, it would still be connected by addition and subtraction. So in this case, our best approach is to move all radicals to one side, and then anything outside the radical to the other. In some cases, you might have to try to just square stuff right away, and in other cases, you might have to do a little rearranging for it to be more efficient. But with that in mind, we're going to go ahead and square both sides here right away. In doing so, well, the right side is pretty easy. 3 squared is 9. Left side, depending on your approach of doing it, you might have to write it out twice, or you can apply the formula to do it. Either way, doesn't matter. But I can apply the shortcut a plus minus b squared, which is the perfect square trinomial pattern, the algebraic identity, which it says it's a squared plus minus 2ab plus b squared. So in other words, this will be the square root of x plus 9 squared, keep the sign the same, twice a, which is the square root of x plus 9, times b, which is the square root of 2x, then plus c, or plus b squared, which is the square root of 2x squared. I'm going to have to rewrite my 9. And that's equal to 9. So you can also do that by distributing. I'll add that in at the end if you want, or if you prefer to use that instead of the formula. But afterwards, we do have to do a little bit of simplifying. Squaring and square rooting cancel, leaving us with x plus 9 minus, I will actually kind of multiply. I'm not going to completely multiply them here, but when you multiply radicals, you just multiply the stuff underneath. So if I rewrite that as one radical, it would be 2x times, in parentheses, x plus 9. And then the last term, squaring a square root, will cancel, giving me 2x equals 9. We're going to combine like terms here. So 2x and 1x makes 3x. So we have 3x plus 9 minus twice the square root of 2x and x plus 9 equals 9. Unfortunately, we still have a radical, so we're going to have to square again. But this is very important. Anything that's connected by addition and subtraction is going to have to be moved to the other side before you do this, or else you're going to keep getting radicals in the equation repeatedly. So I'm going to have to subtract 3x on both sides first, and I'm going to have to subtract 9 as well. This 2 here is connected to the radical by multiplication, so I don't need to move it over, and I can't move it over through addition and subtraction. So we're going to have negative 2 square roots of 2x times x plus 9 equals, my 9's are going to cancel, and I'll have negative 3x. Now I could divide both sides by negative 2 at this point, but that's just going to add a fraction, and it's not really going to get us anywhere. So I'm going to go ahead and just square both sides as my next step. Exponent properties with product of power, so I'll square the negative 2, and I'll square the radical separately, so the square root of 2x times x plus 9 squared. And then that will give us positive 4. Squaring and square rooting will cancel, so we'll have positive 4 times 2x times our x plus 9, like that on the left. And on the right, again, product of power, or power of a product, sorry. Power of a product property will have us doing negative 3 squared, which I'm already trying to square stuff, and x squared separately, which will give us, on the other side, 9x squared. We're just going to have to clean this up a little bit, and then we'll be able to solve it. So I'm going to go ahead and start distributing some stuff through. Distribute my 2x through, giving us 2x squared plus 18x. And then I still have to distribute my 4 through. So if I distribute the 4 through, it's going to be 8x squared plus 72x. And this is going to be equal to 9x squared. This is still a quadratic, so I'm going to have to move everything to one side here. So I'm going to subtract 9x squared on both sides, giving me negative 1x squared plus 72x equals 0. And then since it's a quadratic and there is no c term, it will just be easier to factor this and solve it that way. So the common monomial in both terms is negative 1 and also an x. So if I pull out negative 1x, I will have a positive x squared minus 70, not positive x squared, just a positive x minus 72. And all of that's going to be set equal to 0. Saying each factor equal to 0, we have negative 1x equals 0, which if I divide by negative 1, we're going to have x is 0 for one possible answer. And if we take x minus 72 and set it equal to 0 and solve, adding 72 on both sides, we're going to get x equals 72. So my two possibilities are 0 and 72. But we still have to plug them back up into the original equation, which is now there off to the side. So if I start by plugging 0 in, I'd have 0 plus 9, which is 9. The square root of 9. And then if I plug 0 into the second one, that's just going to turn into 0. So we'll have the square root of 0 is the square root of 9 minus the square root of 0, 3. Square root of 9 is 3, and square root of 0 is 0. So 3 minus 0, that is indeed 3. So 0 works as a possible solution. If I check 72, square root of 72 plus 9 would be 81. So we're doing the square root of 81 minus the square root of twice x, which is 72, and 2 times 72 is 144. So the square root of 144, is that equal to 3? Well, the square root of 81 is 9. 9 minus the square root of 144, which is 12. That is unfortunately not equal to 3. It's equal to negative 3. Therefore, 72 is not a solution. The only solution we have is 0. Okay, on the side note, we're just going to look at distributing this out the long way. If we are distributing it out without the property, we would just write it out twice to start us off. And then we would begin distributing. So as we distribute, we would do the square root of x plus 9 times the square root of x plus 9, which is a couple of different ways of writing it, but I would probably just leave it as the square root of x plus 9 squared. Then we would have the square root of x plus 9 times negative 2, or negative square roots of 2x, which would be negative square roots of 2x times the square root of x plus 9. The order you write those in doesn't actually matter. You can also rewrite this as the square root of 2x times x plus 9 right now. So I'm just going to bring this down. Okay, and then we're ready to distribute out the next term. So we have negative 2x times the square root, or sorry, negative square roots of 2x times the square root of x plus 9 would once again be basically the same thing here. So I'm just going to rewrite that, since it is the same multiplication, just with two different terms. And then negative square roots of 2x times negative square roots of 2x would be positive square roots of 2x squared. And then if I try to simplify it, squaring and square rooting cancels, leaving us with x plus 9. We have two like terms here. Adding them together, we get minus 2 square roots of 2x, x plus 9. And then squaring and square rooting cancels, leaving us with plus 2x. So we'd still get at the same thing if we distribute and combine like terms. It's just a matter of which approach we are more comfortable with, and sometimes which one is shorter. Okay, for this last equation, we're going to solve the equation for y. This is a literal equation. In doing so, we're going to get rid of anything outside the radical first, which is this 1. Remember that if we are solving for y, that's what we want to get by itself. X is on the left side, so we're just going to kind of ignore it. But we'll subtract 1 from both sides here. X minus 1 we can't actually do, so we're going to leave it as x minus 1 equals the square root of y minus 2. Next, we'll get rid of the radical. The opposite of square rooting is to square both sides. So we're going to square both sides, leaving us with x minus 1 squared equals y minus 2. Now, as far as dealing with this x minus 1 squared, you can write it out and distribute it out, or you can leave it as this. Depending on the context of the problem, depends on which way you want to go, which way is better. For now, I'm just going to leave it at this, and I'll also write out the other possible answer. But to finish getting y by itself, I'm going to add 2 on both sides. But because of the parentheses, we can't actually combine that 2 with anything. So it's just going to stay x minus 1 in parentheses squared plus 2 tagged on is equal to my y. So this would be one acceptable final answer. You can also distribute the x minus 1 squared out, which would give us x squared minus 2x plus 1. After combining like terms with the plus 2, we would have a second possible answer of x squared minus 2x plus 3 as also acceptable.